Hi, in this video, we should be discussing a questions regarding coordinate geometry, circles. We will also be talking about algebra, quadratic inequalities, and surds. The question goes, a circle with center C touches the y-axis and intersects the x-axis at x equals to -2 and x equals to -8. Point C lies above the x-axis. In part A of this question, find the equation of the circle. In part B of this question, if the point -3, k lies inside the circle, find the range of values of k. And in the last part of this question, you are to find the length of the chords such that the coordinates of the midpoint of the chords is -3, 5. You might want to pause this video to give this question a try, and when you're ready, keep watching. Let's start this question by going through some of the formulas within the chapter of circles. So the very first formula we have over here, equation of circle is given to be x minus a bracket squared plus y minus b bracket squared to be equal to r squared, with a center a, b and radius r. In the next formula we'll be using very frequently here is the length of line segment joining perhaps a and b points. So if your a coordinates are x1, y1 and the b coordinates are x2, y2, the length between these 2 points can be found by having a square root of x2 minus x1 bracket squared plus y2 minus y1 bracket squared. Now with this formula in place, alright, let us start off this question by sketching out a simple sketch for these two sentences. So over here, I've done a very simple sketch like this. And as you can see here, a circle with center C, it touches the y-axis and intersects the x-axis at both -2 and -8. Point C, which is the center, lies above the x-axis. Now, what happens for this question is that my understanding is that the perpendicular bisector of this chord joining -2 and -8 will always pass through the center. In other words, the center lies on the line of x equals to the midpoint of these two. So having said that, let us apply this part here in our first step of part A. So in our first step of part A, we have this. So over here, -2, 0 refers to this coordinates, -8, 0 refers to this coordinates. So based on the properties of circles, whereby the perpendicular bisector of this chord will pass through the center, so the x coordinate of the center here will lie on a -5. If I take -2 plus -8 divided by 2. So we have the x coordinate of a -5 for the center. Now let's move on to the next step over here. As you can see, assuming my center of C, and I'm going to let it to be -5, p, where p is a constant to be found later on. So by that, I'm referring to this part of the center, -5, p. So over here in my next step, I'm going to do a dotted line over here. As you can see here, this part from the center to the y-axis over here, this line in dotted lines is actually referring to the radius. Now, since x is a -5 like this, then the radius, my understanding, is 5 units. And radius can also be found by having the length of line segment between these two coordinates over here, these two pair of coordinates. So over here in our next step, we have here. So the length from C, point C, which is the center, to -2, 0 is the same as the radius. As we can see, it's the same as radius. So to find the length using the formula in yellow like this, -5 minus away -2 bracket squared plus p minus away 0 bracket squared, whole thing square root, should give us the radius of 5 cm or 5 units in this case. So solving for p will actually give us a -4 or p to be a 4. Now, since according to this question, point C lies above the x-axis, for a point to be lying above the x-axis, it means to say it should be a positive value. Point P, your P here should be a positive value. So we reject all negative, because if it's a negative, it falls below the x-axis. Now with your point P like this, we can therefore rewrite our center C. So center C over here is a -5, 4. So -5 is found earlier just now. 4 is replacing the p here. Alright, so plugging in this formula, x minus a bracket squared plus 1 minus b bracket squared equals r squared. So x minus a -5 should actually be x plus 5 bracket squared. Y minus a 4 bracket squared equals to the radius. Radius was found earlier. This is the radius part. Alright, 5 squared. And writing in this form and expanding out the 5 squared should actually give us a 25. So the part A answer for this will be x plus 5 bracket squared plus y minus 4 bracket squared to be equals to 25. And that's the answer for part A. Now moving on to part B. In part B of this questions, if the point -3, k over here, assuming my point -3, k is here, lies inside the circle, so it could be anywhere there is inside. So -3, k could be anywhere in this half of the circle. Alright, you are to find the range of values of k. Now, in order for us to proceed to do this question, we'll be comparing the distance or the length between this point to the center versus the radius. Alright, so in our next step, we have this. So the length from C, which is the center, to this point, -3, k in the questions, if it's lesser than the radius, it means it lies inside. Okay, so since the question wants us to say, the question given us the condition, it must lie inside the circle, so it should be shorter than the distance of a radius as seen like this. Now, if this point -3, k is outside the circle, it will be somewhere here, then it will be more than the radius. The question wants us to put it as inside the circle, within the circle, so it has to be lesser than the radius, the distance. So finding the distance or the length from C to -3, k, so using the length formula once again, over here, -3 minus away a -5 bracket squared plus k minus a p, which was a 4 earlier, bracket squared, and the whole thing square root to be less than a 5. 5 is from the original radius of this circle. Now moving on to the next step, we have simplifying it by squaring both sides. It is understood that the length must be a positive and the right hand side radius is also a positive. So when we square an inequality like this, we don't have to flip because both the left and the right are all positive. So there is no need to flip any symbol. Now as you can see here, this quadratic inequality cannot be factorized. So the only way forward is to move to completing the square method like this. So by completing the square, we will have a k minus 4 bracket squared minus 21, and expressing the -21 over here in this form, over here. So -21 can be re-expressed as the root of 21 bracket squared. So I'm writing in the form of a squared minus away b squared, such that we have a plus b and an a minus b like this. And so, since this quadratic inequality of k squared over here is a positive k squared, that means to say it's a happy face and it's lesser than 0. So that means to say it is a 1 range. So in between, in this case, the smaller number to the bigger number, not inclusive. And that's your answer for part B. K is in between 4 minus root of 21 to 4 plus root of 21, not inclusive. Moving on to part C of this questions, whereby we are to find the length of the chords such that the coordinates of the midpoint of the chord is -3, 5. So this is not a very common question because we are given the midpoint coordinates of a chord, -3, 5. Now let's plug in this information to the existing sketch that we have here on this diagram. So we have a chord here and the midpoint of this chord is a -3, 5. So what happens is that we do know that from the center C to the endpoints of this chord is known to be the radius. Alright, so what happens is we can draw a perpendicular line downwards like this. So as we know earlier from the properties of circles, we're going to use the same one against that the perpendicular bisector of this chord will pass through the center. So what this means to say is that we're going to bisect this part here is going to bisect the chords into 2 points, into 2 parts here, 2 equal parts. So over here, radius is already found to be 5 units just now. What we need to do is to find the length of line segment joining from C to the midpoint of this chord. And after we find this, using a Pythagoras theorem, we can actually find half the length of this chord with times 2 to get the required full length of this chord. So that is the general direction for solving for part C. So over here, let's start our part C solution. Length of point C, the center of C here, to the midpoint of chord is found by using the length of line segment formula again, -5 minus a -3 bracket squared plus 4, center is 4, minus away a 5 bracket squared, you whole thing square roots, you're going to have a root 5. So your root 5 actually refers to this part. Let's plug it in. Root 5 actually refers to this, the length of this part here. Your radius was found to be a 5 units earlier. Alright, radius was found to be a 5 units earlier like this. So using the Pythagoras theorem, we're going to find this part here. So we're going to find half the length of this chord and we times 2 to get the full length like this. So half the length of this chord that I highlighted over here is found to be a square root of radius squared minus away root 5 bracket squared. You square the whole thing. To find half the length, you times 2 to find the full length, giving the full answers of a 4 root 5 units. And that's the answer for this whole questions. I hope you have learned something again. Thank you for watching and see you in the next one.